Next I'm going to do example 2. Example 2 is a little bit different because it is squared. Makes it quadratic. The first thing I'm going to do is rewrite the squared with what it's actually squaring. When you have a square tucked between the trig name and the x, it really means tangent of x squared. So when the squared is there, you're really squaring the whole trig function. So now let's solve for x. We'll first get rid of the 1, so we'll add 1 to both sides. Then we'll get rid of the 3, divide by 3. And then we'll get rid of the squared, square root. And when you square root a fraction, you don't have to square root the whole fraction. You can square root the top and the bottom separately. So square root of 1 over square root of 3. Square root of 1 is a perfect square. It's 1. So I have 1 over square root of 3. Now, that can be simplified even more by rationalizing the denominator. Multiply by square root of 3 over square root of 3, and you end up with plus or minus square root of 3 over 3. So I need to solve for x, so I will tangent inverse this side to get my tangent inverse and my tangent to cancel. And then I'll tangent inverse this. So I need to take the tangent inverse of square root of 3 over 3, plus and minus. Tangent inverse is looking at the right-hand side of the circle. I need to take, because tangent is y divided by x, I need to take the y number divided by the x number and see what I'm going to get this. 1 divided by 0 is undefined, that's not it. 0 divided by 1 is 0, that's not it. All of these will be negative, so if I'm looking for the positive version, I really only have these to look at. And if I take y divided by x here, they're the same, so the tangent would be 1. So it's either pi over 6 or pi over 3. And with this one, it's actually pi over 6, because when you take half divided by square root of 3 over 2, it simplifies to be this. This is the same ordered pair, but one of them's a negative, so we would get a negative answer. So my answer is pi over 6 and negative pi over 6.